Welcome to the General Physics End of Topic Multiple Choice Test, where we were supposed to do 40 questions in 45 minutes under test conditions. I'm now going to go through each question one at a time and explain where the answers came from. So question number 1. A student wishes to determine the density of an irregularly shaped stone. First he finds the mass of the stone. Next, he lowers the stone into a measuring cylinder containing water. The diagrams show the measuring cylinder before and after the stone is lowered into it. How should the student calculate the density of the stone? Well, the formula for density is quite clearly mass divided by volume. And what the student needs here is the volume of the stone, because it's already been said that he's measured the mass previously. So how does he measure the volume of the stone? Well, it's quite clearly reading 2 subtracted reading 1. So it's going to be density equals mass divided by volume. So it's going to be the mass of the stone divided by reading 2 minus reading 1. Hence, the answer is D. Question number 2. The diagram shows an enlarged drawing of the end of a meter rule. It is being used to measure the length of a small feather. What is the length of the feather? Well, quite clearly, by looking at this section of the meter rule, it starts at 10 millimeters and it finishes at 29 millimeters. Now, the mistakes in this kind of question is a student starting from 0 and not noticing that it starts from 10, or the other issue might be students not being able to figure out what each of these little lines, these increments, represent numerically. Now, the way to do this is pick any two numbers, such as 10 and 20, and count the increments in between, remembering to always count the last one. So if you count the increments in between, 1, 2, 3, 4, 5, 6, 7, 8, 9, but you must count the last one, which makes it 10. The difference between 10 and 20 is quite clearly 10. 10 divided by 10, each increment represents 1 millimeter. So we've started at 10 millimeters and we've finished at 29. 29 minus the 10 will give us 19 millimeters. Now, millimeters, not centimeters. The centimeter scale is at the bottom. So the answer has to be A. Question number 3. An object of mass 50 kilograms accelerates from a velocity of 2 meters per second to a velocity of 10 meters per second in the same direction. What is the impulse provided to cause this acceleration? Well, the formula for impulse is Ft equals mv minus mu. In other words, impulse is equal to change in momentum. So if you find m times v, which is mass times final velocity, minus m times u, which is mass times initial velocity, that will give you the impulse. So here we've got 50 times 10 minus 50 times 2. Stick that in a calculator and you will get the answer B, 400 Newton seconds. Question number 4. The diagram shows an object of weight W and an object of weight Z balanced on a uniform meter rule. Quite clearly, this is a moments question. Which equation relates to W, Z, A and B is correct? Well, since it's balanced from the picture, clockwise moment equals anti-clockwise moment. Now, I hope you can see it's the weight of object Z that causes the clockwise moment, because if it was allowed to, it would tip in the clockwise direction, and the moment with regards to weight W is the moment in the anti-clockwise direction. Since it's balanced, the force times the perpendicular distance from the pivot in the clockwise direction is equal to the force times the perpendicular distance from the pivot in the anti-clockwise direction. In other words, W times A equals Z times B. So which one kind of relates to this? Well, if you look closely, the answer is C. Question number 5. A train begins a journey from a station and travels 60 kilometers in a time of 20 minutes. What is the average speed of the train? Now, average speed is total distance divided by total time. However, here the distance is given in kilometers and the time is given in minutes. But all of the answers are in meters per second. So we have to change the distance into meters. 60 times 1000, because there is 1000 meters in a kilometer. And then 20 minutes times 60 seconds to change the time into seconds. And then if we do speed equals distance divided by time, you should get 50 meters per second. The answer is C. Number 6. An object has a mass of 50 kilograms. The gravitational field strength on Earth is 10 newtons per kilogram. The gravitational field strength on a distant planet is 4 newtons per kilogram. What is the weight of the object on Earth? And what is the weight of the object on the distant planet? Well, weight equals mass times gravity. So on Earth it's 50 times 10, which is 500. It's 500 newtons. And on the distant planet it is 50 times 4, which is 200 newtons. Be careful, it's not C. The answer is D for donkey, because weight is a force. It's measured in newtons. It's not measured in kilograms. That's mass. That's the amount of matter in an object. Number 7 is a Hooke's Law question. An experiment is carried out to measure the extension of a rubber band for different loads. The results are shown below. Which figure is missing in the table? Now, the formula is F equals Kx, where F is the force or the load in this case, K is the spring constant, and X is the extension. Now here what they've done is they've given you the force or the load, and they've given you all the extensions, and you've got a length that is missing. Now remember, extension is new length minus the original length. Okay? So once again, extension is the new length minus the original length. So what do you do here? Well, the original length is 15.2. So if you look at where the load is 1 Newton, the length there is 16.2. So the extension is 16.2 minus 15.2, which would give an answer of 1. Similarly, if you did 18.6, which is a new length with a force of 3 newtons, minus the original length of 15.2, you would get an extension of 3.4. So what do we do here? Well, since extension is new length minus the original length, then new length equals extension plus the original length if you rearrange that little expression. In other words, the new length here will be 15.2 plus 2.1, which is 17.3. Now, just to help you fully understand that, if I work that backwards like I did with the other examples, 17.3 minus 15.2 is indeed 2.1. So the answer is B for ball. Number 8. A student wishes to find the volume of a small irregularly shaped stone. A ruler and a measuring cylinder containing some water are available. Which apparatus is needed? Okay, so all they want here is the volume of the irregularly shaped stone. They're not wanting the density, so all you really need here is the measuring cylinder, because what you will do is gently lower the stone into a measuring cylinder with some water inside, and providing the water will submerge the stone, the water level will rise. This is known as the displacement of water method, and the new volume minus the initial volume will give you the volume of the stone. Number 9 is a momentum question. A gas molecule strikes the wall of a container. The molecule rebounds with the same speed. What happens to the kinetic energy and what happens to the momentum of the molecule? Well, if it has the same speed, then Ke is a half mv squared. Quite clearly it has the same mass, so the kinetic energy will not change. It'll be exactly the same. So the answer could only be C or D. Now, quite often here students will get confused and they'll pick D because they remember the total momentum before a collision is equal to the total momentum after a collision. The thing is here, we're actually only focused on the gas molecule. The total collision here also involves the wall, and yet we're ignoring the wall in this process. So what I'd like you to understand is the individual momentum of the gas molecule will not be the same before and after, for a couple of reasons. First of all, it's also changing direction, and momentum is a vector. It has magnitude and direction. Secondly, it's the total momentum before a collision and after a collision that's conserved. What that means is we've got to consider the wall. However, here they're only considering the gas molecule, so basically the momentum before and after for that individual molecule will not be the same. There will be a change in momentum. So the answer here is C. Question number 10 is a centre of mass problem. The diagrams show 4 objects A, B, C and D. The centre of mass M of each object is marked on the diagram. Which object is not in equilibrium? Now what they mean by that is, which object is going to tip over? When the centre of mass is in between the base, then the object won't tip over. So here, A is not going to fall, B is not going to fall, D is not going to fall, but C will fall. Why? The base is right here. The centre of mass is to the right of the base. This will tip over in a clockwise direction.